Thank you, James. Welcome, everyone. So this is the third session on JavaScript foundations, and today we'll be, going in depth of asynchronous JavaScript, promises, callbacks. So especially if we are new to JavaScript, then we often encounter things like callbacks, function passed as functions. We often encounter, set timeouts with timeout set to 0 and promise.all, promise.any, and all those things. So hopefully by end of today's session, so these things will be much more clearer to us. Okay, so first of all, to begin with absolute basic, uh, what is the difference between asynchronous code and synchronous code? So basically, synchronous code is a step-by-step code. They are executed one after another. So until line one has completed, line two won't execute. Until the function one is executed, function two won't execute, and function three will wait for function two to execute before it is executed. So it's a bunch of code in sequence. So if we execute this piece of code where we have four functions and they log something, it will print 1, 2, 3. This is running in sequence. This is called a synchronous code. Okay, just so that we are all in the same page. I'm starting from absolute basic. And so a problem with this kind of a code is that, what if this particular function 2, is a time consuming thing. Suppose it's doing an image processing, it's reading a file, it's it's fetching some data, it's awaiting a response. So until this line of code gets executed, hmm, so if it's a long time consuming process, we will have a user experience something like this. you know the the user won't be able to click, the user won't be able to scroll, and everything will be frozen, which won't be a very good user experience. So JavaScript provides us a lot of asynchronous you know functions and ways to achieve asynchronicity. And and what asynchronous code does is it allows the other lines of code. It does not prevent or it does not block the further code to be executed. So if the function 1 is a synchronous function, function 3 is a synchronous function, and function 2 is an asynchronous function with a long time consuming process, so our output will be something like this. Output 1 will be done, 3 will be done, our screen, our browser will be responsive. And whenever this time consuming process will end, then that will be handled. Okay, JavaScript knows how to handle that. So if we look at a quick example, again, I have written lots of example for this particular session, lots and lots of examples, so that the fundamentals are absolutely clear to us. I'll share link to this, and in case we have any doubt at any point of time, please feel free to reach out to me. So here is the same function which we looked at the slide. There are three synchronous function, and we are calling them one by one. And if we save it, we will get 1, 2, 3 as expected, because they are logging 1, 2, 3. Okay, and if we have an asynchronous function, and we will place it after function 1. Okay, so this is an asynchronous function because set timeout is a web API function, which makes the code asynchronous and non-blocking. And there is a time consuming process here, and I'll just write something else here as well. Async 2. Okay, And now we are calling async function actually um, after function one. Okay, and let's delay it by 1 second. Okay, so set timeout basically takes in a function. The function is run in a non-blocking way, and if we provide a time here, so it will delay its execution for like 1 second. So here, if we save it, so instead of blocking the rest of the code from running, async2 ran after, this line of code was executed after 1 second without blocking any of this. So this is called a non-blocking asynchronous behavior. Now, one thing you will often see in the in a code base is that often to make things asynchronous, so here we pass in 0, so we don't give any delay to our set timeout. So if I save the code, can someone tell me that where will this async2 be printed? We are calling async function to the second, and it is situated in the as a second function. We have set the timeout delay to 0. Okay, so there is no delay. So where will this line of code be printed? Just think. So actually, if we see, it prints at last. Okay, when all the synchronous operations are done, after that, this asynchronous function takes place. So this is another fundamental, many times, um, if this fundamental is not clear, things looks confusing. So the purpose of making things asynchronous is to let the synchronous function do its job. And once synchronous functions are done, then asynchronous function takes over. I have oversimplified the thing. There is something called event loop and task queue. Okay, I have added notes about this in one of the resources that I'll be sharing. And whenever we get some time, let's just Google this. What is an event loop? What is a task queue? So how this asynchronicity works, this will be 100% clear to us. And this is so fascinating. This makes JavaScript the powerful language that it is. Okay, so I hope that synchronous and asynchronous code, the fundamental behind that is absolutely clear to us. Now, the second thing is callbacks. What is a callback? And and people coming from Java and other backgrounds, they find it really confusing. So see, uh, here I have implemented the callback pattern. So how do we know that we have implemented a callback pattern? So we have a function called process user input. It takes in first name, last name, and callback. 3 parameters, 3 arguments. Okay. And one of the arguments we are invoking as a function. So whenever you see or encounter this kind of a pattern where one of the argument is invoked as a function, or in other words, when a function is passed as an argument to another function, that is called a callback pattern. Okay, so again, let's see a little bit in more detail. So what happens when we invoke the process user input? We need to pass 3 parameters, right? So first parameter could be anything, John. Second parameter could be Doe, his last name. And what will be the third parameter of the process user input at the time of invoking it, at the time of calling it? It will be a function, okay? Because it's a callback pattern and we are invoking this function in the in the in the code that has declared it. Okay, so and here in the function process user input, we do some processing with the first and the last name, and we form an intro text. and we pass that intro text to our callback function. Okay. So here, when we invoke this process user input at any later stage, we get access to the intro text and we can do whatever we need at that time. Okay, we can print it, we can log it, we can do some calculations with it. It's totally flexible and it's up to us that here what we do with the intro text that we get. Okay.
So,
Yeah.
Vivek, are you open to questions now? Means,
Yeah, yeah, please. I mean, that will make, it much
yeah.
more useful.
So basically, this kind of callbacks are generally used as in when we have dependencies on other functions, right? So let's say if
Correct.
I have to fetch, let's say if one of my testing application has to fetch one of the texts that's there on the UI, I get it on the text and I save it as a parameter
Hmm.
just to show it and have an assertion. So I can just use this kind of callbacks, right? Rather than like putting direct assertions. Assertions can be one of the way, but this is also one
Hmm.
of the most possible ways, right?
Yeah. So so there are actually multiple ways to do that. Okay. And we don't do that using callback these days. Okay. But
Mm-hmm.
why I am talking about callback before moving into promises and async await is because under the hood, JavaScript uses callback. This is a very good question. Let's look at a few examples. I was actually planning to skip the callback related examples, but it's interesting. Let's look at those. Sounds good?
Yeah, sure.
Yeah. So let's straight away go to the code base. Okay. And here also, you can see I have written lots of examples. And not just now, at any time, if we have any doubt related to this, this is why the Learn.js club is for, right? Just feel free to drop a query. And if something is like more confusing, then maybe next week or the next week we can keep another session on that. So first, let's even though we won't be using callback much because we now have promise pattern and async await pattern, but still, if we understand it clearly, it will be very, very useful and it will help us understand those patterns better. Okay. So here I have created a function that returns. Okay. Okay. Let me keep it very simple. So here is a simple function, again the same one, which takes in first name, last name, and the callback. Okay. And I have processed this information and I have done it synchronously, not asynchronously. So this is a synchronous operation. This is a blocking operation where I am taking the first and the second parameter and forming an intro text. So we did something. And then we execute our callback function with the intro text. Okay. And now when I'm invoking the process user input, I am passing in the first name, last name, and a function. It gets access to this intro text, and I'm console logging. Um, Maybe I can write something here to make it a little different. Say coming coming from maybe line 16, whatever. Okay, just to keep it simple. So now if I save it, so we can see that this function got invoked and we are we get access to intro. So how this intro is formed, we don't we don't we don't care about that in while calling it because that is taken care in this function. And we get intro and we can do whatever we need to do with intro here. Now this is a super simple example. Let me increase the complexity just a little bit. Okay. Still, it's a synchronous execution. It's not an asynchronous execution, but I have added a little bit of, I have moved it one step ahead. Okay. So now I have a function called calculate. How do and we use callback pattern here. How do we know that we are using a callback pattern here? Because one of the parameters is executed as a function. Okay. As soon as we see that one of the parameter is executed as a function, or a function is passed as a parameter, we know that we are doing something like a callback pattern. So what it returns is it invokes the callback and passes it both the numbers. Okay. What the function calculate does is it adds, multiplies, subtracts. That will happen at the time of calling, not at the time of declaring the function. Okay. So we have kept it super flexible, calculate, and the callback function. Now, how we invoke it. So for example, I calculate 2 and 5, number 1 and number 2, I pass it. And then the third argument is a function. Now, this is a simple arrow function, which is equivalent to this kind of a code, function AB, which returns A plus B. So it's a shorthand way, and a lot more than that. But for now, since we are not using any this here, so it's just a shorthand way of writing this, where a function takes in 2 arguments and returns A plus B. Okay. So if we see, this line returns 7. Okay. The same calculate function, because of the callback function that we passed in, because of the function we passed in as a callback, we are getting a different result. And here for line 29, again for the callback function, we are taking 2 arguments and multiplying them. So again, the same number is giving us a different result. Okay. So we have slightly increased the complexity. Okay. So we are actually using a little bit power of the callback. Now I'll straight away move to a real life asynchronous example. So asynchronous are like set timeout, event handlers, the fetch. Okay. So let's actually see 100% real world example. Okay, let's write it together. Okay, and I want to use a very practical use case, so that this is something that we do often while writing tests and writing code. Okay, so this is Json Placeholder. This is a fake API and a very useful API if you want to just practice JavaScript. So basically, I'll show you how the API looks like. So for example, when I queried JSON placeholder and this URL post one, I got a blog post, a dummy blog post. When I write two, so I sent a request for blog post two, I got that response back. Okay, so it's a real thing. Okay, and if we want to learn more about its API, just remove everything after the main URL, and this is the placeholder. So we have like 100 posts, several comments, albums, photos. You know, we can do all these operations using this URL. So here, let's use this post one to write a real asynchronous code. Okay. So I will again go back to callback design pattern, and so what I can do here is everyone with me? Please let me know in case I need to, move things quickly or go into a much more depth. If things look clear, then just tell me that, yeah, we can, we can skip the example and move with greater speed. And if you and in my opinion, getting in depth of foundation is much better way to go about things, rather than learning 1,000 different things. Learning one thing in depth is much more valuable. So let's write a function called function get post one, and what it will be doing is it will be an asynchronous function. So, or let's put it get post, and the post, it takes in post number, for example, and maybe a callback. Okay, and what will it do is it will fetch the post. It will fetch the post number, okay? And then we'll get some data back. We'll get some response back. Then we get some response back. And what we'll do is we will convert. So don't get into more, what we are doing here, what we are doing with response, etc., but how we are using callback. So that is our focus here. And with the response, we can return the JSON. So what .json does is the response has a body thing, and that body, it converts into a JSON object. Okay, that's what this JSON does is, and again it returns a promise. So promise we will just look, and then once I get the data, now I have a fully formatted data. What I can do is maybe I can call the callback and pass in the data. Okay. So this here we have executed a simple callback thing, which in real life these days we'll be doing using promises and async await, but still it's very valuable to know how things happen with the callback. So here basically we have created a function called getPost. It takes in post number and a callback. So what it does is it encapsulates how we are fetching the data, how we are making a request and getting a response. So we see that we are fetching it with the post number. And once we get the response, we are invoking our callback function with that data. Okay. Now let's use this function. So I'll do get post. Okay. And then I'll maybe this time I want to see post number 2, say. So I'll pass in post number 2 and then a callback function. Okay. So for callback function, I'll get something back and I'm free to do whatever I want to do with that here. Okay. Whether I want to do some sort of processing or anything. Okay. For now, I'll just console log the data that I've received. So I've called the get post. I've passed in the post number 2 that I want to fetch. And then I have simply displayed the data. Okay. And now once the operation finishes, once it's able to fetch the data, so we can see that here we are getting our post, right? So we have just implemented a callback pattern where we have written a function get post, which is flexible enough to fetch us any post. And because of this callback pattern, we are free to do anything that we need to do with the data. Suppose I want to just print the title. So here I can just print the title. And we will just get the title here. Got it? So this is the way we write and we use callback function. And we will see a much modern and a much better way of doing that. I leave this example here so that it is for our reference. And there are several other examples, several other kind of real world examples. So please go through them whenever you get some time. If we are writing any JavaScript, getting very good at its fundamental is like saving lots and lots of time and lots of frustrations, right? So does this help? Does this example help how we use callbacks for an asynchronous real fetch function, right?
Yes.
Great. Okay. So yeah, so callbacks we have already seen in action. Now, what is a problem with callback is often, after 3 or 4 levels of nesting, first request we get a response, then we need that response to do something with it, then we make a second response, then a third request, and soon it becomes very, very unmanageable. This is referred to as callback hell. you know. So, up to a few levels, like 2 or 3 or 4 levels of nesting, it's okay. But when it goes more than that, then it's not a very good experience. It's very hard to understand. Okay. So then comes the promises. So promises are much cleaner way to handle, or the modern way to write callbacks, we can say that. So we are able to handle asynchronous operations in a much more reasonable way, much more intuitive way, and we can handle errors in a much better way. Okay. So we saw the callback hell. This is how it looked, 3 levels of request. And the same thing in promise looks like this. First request, then second request, then third request, then we have final response, and we are doing whatever we need to do. So these were nesting. If we look at callback, these were nesting, and this is chaining. Okay. So in promises, we chain the thens instead of nesting the callbacks. So it's much more intuitive and it's much more cleaner than callbacks. So there is a function that returns a promise. Okay. So whenever we invoke that, so this is the mindset behind promises. Okay. So if we understand the mental model of how promise works, things will make much more sense to us. So a function that returns a promise. So whenever we invoke that, we get a promise object back. And it has a state which is usually pending to begin with. And then it has a result which is undefined as soon as we invoke it. So after the processing happens, after the task is done, the asynchronous task is done, then the promise state changes into either fulfilled or rejected. And in case the promise was resolved, we get the resolved value. In case it was rejected, we get the rejected data or the error here. Okay, simple. So as soon as a function that returns a promise is invoked, we get a promise object. It has 2 properties, promise state and promise result. And they, in real time, change, and promise state becomes fulfilled or rejected, and their result is updated accordingly. Clear so far? And these promise state and result, these are internal to promise object. We have much cleaner API to use them, called then, catch, and finally. So we don't use promise state or promise result. We have a clean API called .then, prototype functions called .catch, and finally. Okay. So this is a function that returns a promise, and whenever the promise gets resolved, whenever the promise gets properly resolved, then whatever we write inside the then, that is executed. So it again takes a callback. Even though it's a promise, it takes a callback function which gets the message that was passed when the promise resolved. Okay. And we can do anything with that message or data. Whenever the message rejects, whenever the promise rejects, then whatever we write inside the catch function is invoked. So the callback takes argument message, and that message gets access to the error or whatever response we have passed while rejecting the promise. And finally also takes in a callback function without any argument. So irrespective of whether it was resolved, the promise was rejected, it's called every time. It's mostly used for cleanups, and it has no arguments. Okay, so then when the promise resolves, catch when the promise rejects, and finally when irrespective of resolved or rejected, it is called settled. So when the promise is finally settled. Okay, so real world example of promises is fetch, okay, then, and catch. Now, one thing we can do interesting is we can change that callback thing to our promise. Okay, so here we have used the callback pattern. So using promises, how it will look like is simply fetch, and we can pass in whatever. Whatever, 3, let's say. Okay, and then we get a response, and we can return the response, and then it again takes in a function in which we get the data, and we can console log data dot title. Okay, so do you see the beauty of promises? It's chained, you know. First we got first response, and then we got data. So this is so simple, so clean, and so we get it here. Okay, let me see, is it correct? No, it is undefined. So who will help me debug it? So we go to fetch and then response, and let
I
me console
think
log.
return should be response.json.
Yeah, who was that? Thank you very much. So yeah, it should be response.json, because until we convert into the body of the response to JSON, we won't be getting the title and all the fields. So this is the way we write the same thing, almost the same thing, using promises. Okay, great. So yeah, and promises is a big topic, and a very important topic in my opinion. So I'll go through a couple of examples really fast, and then I'll let you explore the examples, okay? Or maybe I'll go through the concepts, and I've put an effort to make things very clear and simple, and then I'll let you explore the examples and experiment with it. So suppose we have multiple blog posts. We have post 1, post 2, post 3. Again, this is a very common use case. We have multiple users, multiple posts, and we want to fetch all the posts. So there are around 5 ways of doing that using promises. The first is a chain of thens. Okay, so we fetch blog post, then blog post 1, and then we get some data, and then again after we get that data, we um, make another fetch of the second post, and then another for the third. So we are chaining the thens. Okay, so in this we are able to make a request for next blog only when the previous promise is settled. Okay, even though this is not blocking anything, but inside this chain, then we are dependent on the previous one. So a use case of that is that suppose the first response gives me detail about a user. Okay, then I need that user's author ID to get its post, and then I need that post to get its comments. So for those kind of related things, step-by-step things, this chain thens are useful. Okay, now most of the times we will want to make several requests together, right? So it should go searching for data together. And once we get all the response, then we can use that data. So this is a very common use case. So we use Promise.all for that. So we make several requests and wait until all of them are resolved. Okay, once all of them are resolved or fulfilled, we get a new promise. We get a new promise of with an array of responses. And if any one of these rejects, the whole of the promise gets rejected. Okay, again, that is a very common use case where we want all or nothing. Suppose in a bank transaction or in an accounting transaction, we either want everything to happen or nothing. Debit, credit, and stock register all must be updated or nothing must be updated, right? So in those all or nothing scenarios, Promise.all is very useful. Then suppose we don't want the promise to reject if any one of them rejects. Basically, we just want to wait for all the promises to settle regardless of fulfillment or rejection. Okay, so then we use Promise.all.settled and we pass in as many number of promise objects that we need. We get back another promise when all of them resolves, all of them settles, and we get an object something like this here, which has individual status and value. Okay, so irrespective of they were rejected or fulfilled, we will get the data. Now, this is also a very common use case. In fact, I found myself using this the most, that there are multiple asynchronous tasks. They can run in parallel, excuse me, and we want to know the result, what happened to all of them, right? So for them, Promise.all.settled is useful. And another thing is that, we just want the first settled promise. So like we have spinned up 10 promises, and the first one that, settles, either resolves or rejected, we want that as a result. Okay. So in that use case, we use Promise.race, and Promise.race is like the fastest one will win. So if the first one or the fastest one is rejected, the whole of the promise is rejected. So in Promise.race, the fastest one wins. If it's rejected, the whole promise is rejected. If it wins, if it resolves, the whole of the promise resolves. Okay. And another, very common thing is that we want the first fulfilled promise, not the rejected promise. Suppose the first promise is rejected, we want to ignore that, and we want to find the first fulfilled promise. For that, we use Promise.any. So what happens is that it waits until it gets the first promise that is fulfilled, in which we get some data, which is resolved. And we get that result, and we can use that. And in case it fails only in one condition, where all the promises fail. Okay, all the promises rejects, then Promise.any will also get rejected. Fine. So its use case is that when we want the fastest fulfilled promise, win the race, that is the use case for Promise.any. So we have 5 ways of 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 invoking multiple promises: chain of thens, when one is dependent on another; Promise.all for all or nothing use cases; Promise.all.settled to run multiple unrelated tasks; .race, the first one to be win; and .any, the first fulfilled one to win. So these are the 5 things. And again, I'll provide a link to all of these. I've added lots of examples, almost 206 lines of examples for you to just practice it, and to make it clear. I've tried to make them as real life as possible. Okay, using the Git APIs, the Json Placeholder, etc. And once we play around with it, it will make much more sense, and it will be fun. It's easy. Once we understand it, it's super easy. Okay, so thank you very much. Hopefully things are much more clearer with promises and callback. And in one of the future lessons, we will learn about async await function. And also, in case we have any queries, just feel free to reach out um, to me, to Sagar, to James, and please ask lots of queries. That's how we will learn from each other. And wish you all the best. Thank you very much for being such good participants. Thank you.
Thank you.
Thank
Thank
you.
you very much, Vivek.
Thank you.
I
Any
felt like a
questions
classroom.
on this session today?
Yeah, sorry. Um, yeah, I lost the voice stopped.
No, like, do we have any questions for today's session?
Yeah,
Please
yeah,
feel
yeah.
free to ask.
Please feel free to ask, please.
Vivek, if I had to pull a list of blog posts from website, which is the best Promise, like Promise.any or like what would you suggest?
Yeah. So usually promise. So yeah, I'll just share my screen quickly. So for that use case, in my opinion, again, um, in I find myself using Promise.all settled most of the time. So for example, I have 10 blog posts, okay, and I was able to find 6 of them, and 4 failed. Sorry, I think I have not shared my screen. Yeah, now it is shared. So I find myself using Promise.all settled most of the times, because in that way, suppose I have 10 blog posts and I am able to fetch 8 of them and 2 have been rejected. So I know what to do with them. I have a bit of more flexibility with all settled. I have all the results. And another way, this is like a very basic uh, thing. And another one is like what happens, that individual promises or individual requests are triggered for each of them. So as soon as one of them gets resolved, it is printed in the screen without waiting for all of them. So they are
So,
in,
which means it does not make a difference on the performance necessarily, right? I
yeah,
just thought
if we
like
make,
Promise that race would just load it faster if the fastest one wins, right? So
yeah,
would
yeah,
the
this is,
response change
yeah,
in
this
that
is
case?
correct. So these things are these 5 static things of promise is useful when they are somehow connected to each other. Okay, we want something to happen with a group of promises. In that case, what the your question is, that if I want to fetch, suppose I have a website, it has a list of blogs, and I want to fetch 10 blogs. So at that time, those are individual promises, right? And I think it will, for that case, it will make much more sense if I let them individually fetch them. So for each of them, there will be a separate promise, and as they get resolved, they will keep up. And we have seen that, right, in several applications, like in React Post. So as we scroll down, so there are multiple requests, and as they get resolved, we are able to see them one by one, right? So I think for that use case, in fact, none of these are most suited. Individual promises or individual requests will make much more sense there.
Okay, that answers my question.
Right. And if we have to use, if somehow they are related, then I'll prefer using all settled, because I have much more control over the result that I get. Again, this
Like
is very subjective.
yeah.
Yeah. Great. So please, I'll share all the links on all the notes, and please feel free to spin up discussions. We'll be happy to help each other and become better JavaScript developers. Thank you.
Thank you, Vivek. Thank you. Thanks a lot. That was a really a great session. Thank you all for joining the session today. So the materials used, the recordings for the session all will be updated soon into our knowledge sharing application for your future reference. So yeah, thanks for joining the session today. We'll see you all in the next month Learn Club JavaScript session. Thank you, Anand.
Thank you, Vivek.
Thank you.
Yeah, it was a nice session.
Great to see you, Boris.
Yeah, thank you. Did you like? Are there any books like to be used like as resources?
My favorite book is MDN, Mozilla Developer Network.
MDN. Okay.
I find myself referring to that most of the times,
All
and
right.
I'll put several links to those documentation because what is MDN? That is JavaScript specification
Yeah.
written in normal language that we can understand. So that
Yep.
is purest form of documentation,
Yep.
and documentation and source code. These both are most reliable source of information.
Yep. I agree. I agree.
So
I'll have a
MDN,
look at them.
sure,
Yep.
please.
Yep. Okay. Thank you. Have a good day.
Thank you. You too. Bye.
Bye.